All right, so some of you really wanted to see problem 99 from the section 1-1 homework, which was all about angular speed. So we didn't do that one in class because we were still getting to that, and we've done that concept now, and we double checked it today, but I wanted to make sure we went back, and just in case some of you needed help, it's a little bit more of an involved problem just from a unit conversion aspect. So anyway, here's problem number 99 right here. And when you look at this problem, it's all about reading it first. So it says a car is moving at a rate of 65 miles per hour. So that's how fast the car is going. All right, so 65 miles per hour. And the diameters of its wheels is 2.5 feet. That seems interesting. So instantly I want to kind of make a picture of, wow, that's a bad picture. I want to make a picture of one of these car wheels, because then hopefully I can use that to start to understand the question itself. So I know that on this wheel the diameter happens to be 2.5 feet. If I can get the pen to write there. Alright, so 2.5 feet. And it'd probably be nice if we make that decimal. There we go. Sorry about the fact that it looks like 2 times 5. Anyway, so 2.5 feet. And I want to figure out the car is going at 65 miles per hour. So the car is going because these tires are rotating. And they're rotating. So these are probably rotating pretty fast to be going 65 miles per hour. So I know the number C is going to seem to be big. So anyway, I want to know exactly 65 miles per hour. This tire's in feet. That just doesn't seem to work for me. So I'm going to start with that 65 miles per hour. Miles per hour. And I want to convert that to feet. So I know that there are 5,280 feet in a mile. And that's going to help me. Wow, my pen is not writing. That means that the miles are going to cancel out for me, and I'm just going to be left with feet per hour. You can see the feet in the numerator. It's the only unit left in the numerator, and then hours in the denominator. So that's awesome, but I really want to know, let's go in the question. It says find the number of revolutions per minute the wheels are rotating. Revolutions per minute that the wheels are rotating. So I want to figure out how many times this wheel is spinning in 1 minute. So I don't like the fact that I have hours then, so I really want to convert out of hours. I'd like that hour to become minutes. So I'm going to have to use another unit conversion, and hours are going to go on the top so they can cancel out. Numerator and denominator will cancel. And I know that 1 hour is really 60 minutes. So that'll help me cancel out my hours there. And that means I'm now at feet per minute. I'm at feet per minute. I can see that feet's the only unit left in the numerator. Minutes is the only unit in the denominator, so I'm at feet per minute. If I do all the calculational work here, which I could do 65 times 5,280, divide by 60, and I would have my number of feet per minute. But I want revolutions per minute, and I also... So revolutions per minute. And I also want the angular speed of the wheels in radians per minute. Now for me, at this point in time, both of those are per minute, which is what I have. I'm really at feet per minute. I realize that, which is nice. But I don't want feet. So the minutes is great in the denominator, but I don't want feet. I want that to either become revolutions or radians. And I really have a choice here of which one I want to do first. So I need to figure out how radians and feet are connected, or how revolutions and feet are connected. And I really have a choice. So when you look at it, a revolution, that means if I do 1 revolution, that means I'm going to go 1 time all the way around the circle, which means I'm going to go 1 full circumference. So I can either connect the circumference, which is going to be measured in feet, to a revolution, or if I use my idea of a radian over here, I know 1 radian of angle would get me 1 radius of arc length, which that would be 1.25 feet. Now that one sounds easier to me, so I'm going to do that one because, hey, why not keep it easy, right? So I'm at feet and I want to convert to radians. So I want to multiply by, well, there's going to be 1 radian for every 1.25 feet. And so really when I look at that, that means that feet are going to cancel, which is awesome. And that's going to leave me with radians per minute. And I can go ahead and, get the value of that quickly. So I'm going to do, 65 times 5,280. I'm going to divide by 60, and then I'm going to divide by 1.25. And that leaves me with, oh, wrong color, 4,576 radians per minute, which is great. And then, let's suppose I wanted to go back and solve A now, because that was really B. So this is the answer to B. If I want to solve for A, revolutions per minute, well, how is a revolution connected to a radian? Revolution, that's all the way around, going back up to that circle. 1 revolution is 2 pi radians. So if I want that radian to become a revolution instead, really it seems like it's just unit converting again. I'm going to multiply by, let's see, 1 revolution, maybe, there's my E, is 2 pi radians. And so again, when I look at radians, are going to cancel out because I have them in the numerator and denominator, and that's going to leave me with revolutions per minute. Those are my only units left over. You really want to be careful when you're typing in divide by 2 pi in your calculator. You either want to hit divide by 2 and then divide by pi, or you want to do divide by in parentheses 2 pi, because otherwise your calculator won't, it'll actually multiply by pi, not divide by it. But anyway, so there we are at 728.293 rev, and I'm going to run out of space, per minute. So hopefully that should be minute, but I ran out of space. I'm sorry on the end there. So anyway, hopefully that helps you if you're still struggling with this problem. But anyway, have a great night.